Hello everyone, here is the next tutorial on a Ladybug for climatic analysis. In this tutorial, we focus on the sun path analysis. Before we go forward, I would like to talk about two very important points. First is to use the Ladybug plugins and in components, make sure that you're going to change your units to the metric system. To do so, you have to go on Rhino and then run a units command and then change the model units. The layout unit doesn't matter, but the model unit should be a metric. By metric, you can use like meters or centimeters, but I would recommend you to use meters because otherwise you have to rescale some buildings later on, and then some of the diagrams, and then some graphs. The second thing is probably you have already noticed that if you use the Control-Alt and then left click on Ladybug components, Ladybug does not show the location of that component. So you know that if you have any component and then like the original component from Grasshopper, you use like Control-Alt and left click. So that shows you the location of that component. It's sometimes, just like it's a very helpful tool to locate the component for you folks. But in this case, you cannot use them, unfortunately, on any of the Ladybug components. So then you have to master the location of the components rather than relying on the Control-Alt left click. Anyway. So let's jump into our work. So I'm going to move things around a little bit just to show you what we would like to work on. So first of all, I would like to show you the sun path, but the sun path analysis. So you have to go to the tab number 2 under Ladybug, the visualize data. It's Ladybug sun path. So grab the Ladybug sun path. So drag it down and then start using it by only one thing that you need as a kind of necessary data that you have to plug in it into the component. As you can see already, I have like 2 files and then 2 weather data files and then EPW files ready in here. One is for the city of San Diego, and then the other one is in Chicago. One of them I use my computer and the file on my computer. The other one is online. So, and I have already connected to one plugin. So I'm going to turn off this plugin for a second, just to show you what's going on, and then how we use file in here. So you have the location. Either way, you need to get the location in here, and then connect the location from the import location that you learned from the previous tutorial. That's all you need just to show sun path diagram, and then later on we're going to get to the sun location too. Alternatively to this, you can use also EPW, and then by feeding this EPW to get the EPW information. So meaning, instead of just using the location, you can add the EPW file in here, use this, and then feed the EPW, and then get the location as the first data you have, and then connect it to the sun path analysis. It's going to be the same things. As you can see, as soon as you connect the EPW file, the location to the sun path visualization, you see that the data related to the location is coming up. So meaning that if you have the location like Chicago O'Hare, it shows in here. And then if you have like any other places, like in this case, I had like San Diego as a location, so it's going to change to San Diego. So you don't need to worry about like tagging the visualized data. So you can use that and then it automatically is going to be updated based on the data that you have, because we have the location and then location identified in here. Let's move on and then go to the next part. So I have like all the components and the data in here set up. So I'm going to use this and connect this location on the sun path and turn it on. So there are other things also is really important. One is just like you can have the solar time or the daytime, and a kind of standard daytime. By default, this part and then this input is on false. If you don't have a Boolean toggle connected to this, is false, meaning that it's using the solar time. This is false. And then if you change it to true, so you're using a daytime and a standard time. Also, there is another very important piece of data that you can add to this, and that is the exact location of the sun that you want for the exact time of the year. As you know, 24 times 365 days, it's the data that we have for the location of the sun, which is going to be between 0 and 8,760 location information for the sun. As you can see in here, I added 2 numbers. If you add more numbers, so you can get the location of the sun for like 3 locations that you can see in here, 1 and then 2 and then 3. So, but we don't want to do this because this is like very tedious job. So you have to calculate the location of the sun. But instead of doing that, we use the analysis period component, which allows us actually to use month and then also the day, and then it's going to give you the period of time and then also the time step and the time lapse that you have for the sun. In this case, I use the month of April, start and an end. So the analysis of mine is going to be done only in April. So to do so, I use the panel tool by clicking in here, adding number 4, enter, and then make it smaller, and then delete this panel. I don't want it. So this would be the same thing that you're seeing here. Anyway, so start month and then end month, and then also the start date is 15, including 15, and then end day is 16, including 16, and the time lapse is like every 6 hours. Then I have my days and then time that I would like to do the analysis for the sun location here ready. All I need to do is just like connecting this output that I can get from the analysis period to the horizon here. And then as you can see that these are 2 days of 1 month. And then if I increase this to, let's say, 6 days, 15 to 20th, including 15, the 1, 2, 3, 4, 5, 6 location of the sun on the sun trace, well, for noon time frame that you can see in here for different days in April between 15 and 20. And then if you are changing this and then increasing this from, like, let's say 5 April and May, and you can change the end month to May, then you're going to see that what we're going to get. So from April to May, and then you have like all these locations for the sun. And then you can see that the angle of the sun, if you have the your project in here, then later on we'll see how we do the radiation and then sun analysis for your project. All right, just like a few more things. One is instead of also using it with this is scale. This is the scale. This is the default scale. But you can change the scale to, let's say, 0.5. Change the scale if you wish. You can make it smaller and bigger. And the other thing is about the projection of this, and that is 3D version of the location of the sun path and the location of sun. You can have orthographic projection as a 2D, or you can have a stereographic. It's very interesting. You're familiar with orthographic and stereographic. I'm not going to explain that. But if you need to know more about that, put some comments in the comment area of this tutorial. Then I'm going to make another tutorial for the orthographic and the stereographic. It's not only for this, in general in architecture and design. If you would like to have access to the location of the sun in Rhino, so you can bake those as the lines, and then go to bake, and you can put them together as one group and then bake them, and then of course you can move around and then use them if you need, just like to have it on your boards and then in your design. Yeah, thank you very much for watching, and then that'll be all for this tutorial.